Hello, this is Miss Sue and welcome to our virtual classroom. So today we're doing chapter 3J, which is graph of exponentials. So if we're looking at different exponential relations, how do they look like? Yeah. So exponential relation actually has a form of y equals to an integer powered by x. Yeah. So let's look at three very simple positive integers first, which is 2 power x, 3 power x, and 4 power x. So below here, we have a list of possible x values. So I have just selected very simple range of x values, which is -2, -1, 0, 1, 2, and 3. So what happens when we substitute this set of x values into the first equation? We will get the corresponding y values as below. Yeah, so that would mean that 2 power -2 will give us 0.25, 2 power -1 will give us 0.5, and so on and so forth. Yeah, we can see that as the values of x increases, the value of y actually doubles. Yeah, can you see that 0.25, the double of it is actually 0.5, and the double of 0.5 is 1, and therefore it's growing exponentially. So if we look at the second equation, it's 3 power x. If we substitute the values of x into the second equation, we will get a set of y values as below. Yeah, and of course we will see that because the base number here now is 3, the values of y will treble. It will be times 3. And if we look at the third equation, it's a power with a base number of 4. So we can see that all the values of y will be times 4 every time the x increases. So in this case, the y value is doubled. The second one, the y value is tripled. And the third one, the y value is times 4. And if we look across the row here, we can see that when x equals to 0, y has a corresponding value of 1. Yeah, so why is it like that? That's because whatever number you have powered by 0 will return the value of 1. So let's see how this exponential relation look like in graph. So the first one, I colored it red. So y equals to 2x will be this red curve over here. And can you see that every time x increases in value, the value of y actually doubles? Yeah, so this is actually an exponential growth curve because it keeps growing, the value keeps increasing. Yeah, and we can see that for y equals to 3 power x, that's the blue line over here. So this corresponds to the blue curve. Yep, and we can see that, of course, the value of this one, the y value will actually triple, and therefore it's getting higher and higher compared to the first one. And of course, the y equals to 4 power x will be this one over here, where it increases even more. Yeah, so I'm actually using Desmos. It's actually a free software. It can be found in this website, yep, to draw these curves and these graphs. Yeah, you're free to try it with other numbers and see how it actually changes the shape of your graphs. So for the second part, we are looking at what if, yeah, the values are not integers, but it's fractions. Yeah, so we are particularly focusing on fractions that's between 0 to 1. So let's say I'm picking 1/2. So that's actually a half power x. We know previously if it's a y equals to 2 power x, the y values actually doubles every time x increases. So if this is the second equation is y equals to half power x, we know that the corresponding y value will keep halving itself, yep, as the x value increases. Yeah, so can we see that for the first one, which is the one that I actually colored in red, actually is this red curve over here. So this is what we have learned just now, and this is the exponential growth graph because it keeps going up. So for the blue one, because it keeps halving, can can we see that it's actually this one that keeps going down? So this is actually an exponential decay graph. The values where the values keep decreasing as x increase in value. Yeah. And do you realize that actually the values of when x is 2 and when x is -2, the value of the y actually corresponds. They are actually the same ones. They are similar. Yeah. So that is because, yep, let's say we just pick when y has a value of 4. Yeah, that's because in the first equation, when y has a value of 4, actually x has a value of 2. So 2 power 2 is actually 4. So for this one, when x is actually -2, half power -2 actually gives you a 4 as well. So, and we also know that if we observe this row again, so we know that when x is 0, your y has a corresponding value of 1. So it means that regardless of whether the number is an integer or a fraction, when you power it by 0, it returns a value of 1. Yeah, I encourage you to try with other fractions and other values as well and see how they actually correspond to each other. Yeah, so if I actually swap 1/2 with 1/3, it's gonna look different. It's not gonna be symmetrical like this. So I encourage you to try different values if you can. So yeah, just a quick summary. If it's a 2 power x, we are actually looking at the base number here. The y value is doubled. And if we're looking at the second one, this is halved. This is half power x, and therefore the y value is halved. So now we're focusing on a negative and how it affects the graph and how it affects the value. So the first one is what we have done before. Yep, I'm always using the same one for easier comparison. So if we put a negative in front of the 2x, how does it change the corresponding y value? We can see that this is still 2x, so the values are the same, but because we add an additional sign, a negative sign, can you see that now all the values that we have actually have a negative sign in front? So for the first one, we know that everything is double and it's increasing. Yeah, but this one, if it is a negative value and it's double, we know that it keeps decreasing in value. Yeah, as x increases. Yep. So how does this two look like on a graph? So now we're just focusing on the red and the blue one. Please ignore the green curve. We'll talk about that later. So the first one is actually the exponential growth that we had said before. The second one is the blue curve, which is, can you see that it starts with a negative value and it keeps going down? And it's actually symmetrical to the red curve. It's just that it is a reflection on the x-axis. Yeah. So whatever value we have for y initially, let's say y equals to 4, because of the negative in front of the 2x, now it is a -4 instead. Yeah. So let's now look at the third equation, which is y equals to 2 power -x, and compare it to the first equation. Can you see that the exponents are actually, there's a negative sign in front of the exponents. So how does this affect the y, the corresponding y values? So 2 power -x, if x is -2, it will become 2 power -2, which is 2 power 2, that returns us a value of 4. So 2 power -2 and 2 power 2 has the same corresponding y values. Yeah, so these values are the same. Yep. So if we look at this equation, yep, and if we populate, if we put all the x values into this equation, it will return us a set of the corresponding y value. Yeah, and if we plot this one into the curve, we can see that, oh, this is actually also exponential decay because the graph keeps decreasing in value. Yeah. So when there is a negative, okay, the graph will keep decreasing in value. Yeah, because of how the negative affects the corresponding x value. So this green line, which is the third equation, is actually a reflection of y equals to 2x on the x-axis. Yeah, so just a quick recap. The second equation, y equals to negative 2x, is reflected on the x-axis. And if you actually change the exponents into a negative number, it's actually a reflection on the y-axis. Okay, so now we're looking at the intercepts. Yep, the y-intercept in particular. So we know that from just now that the y-intercept is 1. So why is y equals to 1? That's because your x has a 0 value. Yeah, so this is the same as well, although it's smaller. It has a y-intercept of 1. So why is this 1 as well? That's because your x is 0. So we know that when x is 0, anything to the power of 0 is 1. So now if we look at the y-intercept in relation to the negative exponential equations, we can see that we can see that when x is 0, some of the y's has a 1, but some of the y has negative 1. So why is that so? We know that when 2 power 0, it is 1. When negative 2 power 0, we have to do 2 power 0 first, which returns 1. And then because of the negative sign, it has a negative 1 as a value. Yep. So 2 power negative 0 will also return as a 1. And that's why the y-intercept for the first and the third equation is 1. Yep. So for the first and the third equation, it has a y-intercept of 1. But for the second equation, it will have a y-intercept of negative 1. So yeah, I've answered that. So when x equals to 0, anything to the power of 0 is 1. So therefore, 2 power 0 is 1, but negative 2 power 0 is negative 1. So now we are talking about asymptote. And what is asymptote? Asymptote is actually a line that a curve approaches but never reaching. So in particular, for exponential graph, we are focusing on the horizontal asymptote. Yeah, and we know that in this case, the horizontal asymptote is y equals to 0. So if we look at the graphs that we have done previously, okay, we know that, okay, for the graph of y equals to 2x and the graph of y equals to half power x, yep, the horizontal asymptote is the yellow line over here, which is y equals to 0. So this is the line that the curve approaches but never reaching. So if we look at the other graphs that we have done before, yeah, so these are all the exponential growth graph. They also have a horizontal asymptote of y equals 0. So that's the yellow line over here. So that's the end of this lesson today, and happy studying.